Good morning, students. Myself Kukureja Rahul, and today we have to learn about this. Today we have to learn about this mathematics class 9. Okay. So as per the previous lecture, we already learned about the polynomials and zeros of the polynomial. Okay. So standard 9th and chapter 2 polynomial. Okay, chapter 2 polynomials, and as per the previous lectures we are discussing about the zeros of the polynomials. Okay, we are already discussed about the zeros of the polynomials. So as per the previous lectures we are learning about that how to find zeros and how to check that given zeros are factor or not of the given polynomial. Okay, so we already learned about the linear equation or linear polynomial, second quadratic equation. Okay, in the quadratic equation we are already learning about the Middleton splitting method. Okay, to find zeros of the polynomial, and as per the previous lecture, last lecture, we are going on the check for this cubic polynomial. Okay, we are seeing that on the cubic polynomial and check the zeros of the polynomial are factors or not of the given polynomial. Okay, and we already seen that how to find remainder. How to find remainder of this polynomial. Okay, so as per the previous lecture we are seen that how to find remainder using remainder theorem. Okay, using remainder theorem. Now today we are learning about the factor theorem. We are learning about the factor theorem. Okay, so what is the factor theorem? First of all, what is the factor theorem? Factor theorem is nothing but whenever zeros are given, or if zeros are not given, then check. If zeros are given, then check given zeros are factor or not of the polynomial using remainder theorem. And second, if zeros are not given in any kind of polynomial, then first of all assume that given zeros are polynomial or not. Given zeros are factor or not using assumption of the polynomial. Using assumptions, we have to choose values of x and put them in the given polynomials and check that is remainder is 0 or not. Remainder is 0 or not. If remainder comes 0 whenever we put the value of x, okay, then when remainder comes 0, then we say that value of x are zeros of the polynomial or factor of the polynomial. Okay, so in this session we have learned that factor theorem using remainder theorem. Okay, with the use of the remainder theorem. Okay, so let's start. First of all, I'll give you the one example or check. Okay, in the following, use factor theorem to find whether polynomial g of x is a factor of polynomial f of x or not. that my question is given polynomial g of x is factor of polynomial p of x or not. Given polynomial g of x is a factor of p of x or not. Okay, we have to check that. For how to check? First thing, how to check? Whenever I put the value of the x, okay, here two variables, two polynomials are given, that is, one of them is x cube minus 6x square plus 11x minus 6, and second polynomial is given as a x minus 3. Okay, so now I'll consider g of x as a x minus 3. I'll consider g of x equal to x minus 3 and p of x as a x cube minus 6x square plus 11x minus 6. Okay, so as per the previous lecture, what should we do? Using remainder theorem, we have to use g of x. We have to use g of x and take g of x equal to 0. Okay, now I shifted 3 on the second side, therefore my answer of x is 3. My answer of x is 3. Okay, so now I put the value of x in the p of x to check that x minus 3 is a factor or not of the given polynomial. Okay, so p of 3 equal to 3 cube minus 6, 3 square plus 11 into 3 minus 6. Therefore 3 cube is 27 minus 6 into 3 square is 9 plus 33 minus 6. Therefore 27 minus 6 9 are 54 plus 33 minus 6. So therefore 7 plus 3 10, 5 60 minus 60. 60 minus 60 is 0. Now using the remainder theorem, which method I use? I use remainder theorem to check remainder of the polynomial. Now what is my remainder? My remainder is 0. Whenever your remainder is 0, whenever your remainder comes 0, so we should say that g of x is a factor of given polynomial p of x. Okay, g of x is a factor of given polynomial p of x. Okay, clear? This kind of sum we already learned in the previous lectures. Okay, so using this method, what should we found? We found that given polynomial means g of x is a factor or not of p of x. Then this method also said that factor theorem. Okay, this method also called them as a factor theorem. Okay, now whenever we use factor theorem, okay, then remainder must be contains 0. Okay, remainder must be comes as a 0. Okay, or whenever in question that says that if g of x is a factor of given polynomial, g of x is a factor of given polynomial in the question, then we say that remainder must be equal to 0. Okay. Then here the two conditions are we seen that if remainder is equal to 0, then given polynomial is a factor of this second polynomial, and if first polynomial is a factor of second polynomial, then must and must remainder will be 0. Okay. So now here is the question that show that x minus 2, x plus 3 and x minus 4 are factors of x cube minus 3x square minus 10x plus 24. Okay. Then in the question we have to show that given three polynomials are factors of the p of x. Then what can we do? We have to check that value of x in this given polynomial using remainder theorem. Then remainder must be comes 0. Then they are the factor of this given polynomial. So let's start. First take x minus 2. Therefore my g of x equal to x minus 2, then equal to 0. Therefore what is the value of x? My value of x is equal to 2. Now take the value of 2 into p of x. So 2 cube minus 3 2 square minus 10 into 2 plus 24, that is 8 minus 3 into 4 minus 20 plus 24. Now 8 minus 12 minus 20 plus 24, and 12 plus 20, that is 32, and 24 plus 8, that is also 32. 32 minus 32, that is 0. Then now I'll write that x minus 2 is a factor. Okay. Now check second value, x plus 3. So I'll take g of x is equal to x plus 3 equal to 0. Therefore my value of x is minus 3. Okay. Now put the value of x in p of x. Okay. So p of minus 3 equal to minus 3 cube minus 3 into minus 3 square minus 10 into minus 3 plus 24. Okay. So 3 cube is 27 and minus 27 minus 3 into minus 3 square is plus 9 minus minus plus 30 plus 24. So minus 27 minus 27 plus 30 plus 24. So minus 27 minus 27, my answer is minus 54 plus 3 plus 2 5, that is also 54. So my answer is 0. So in this also case we are writing as x plus 3 is also a factor. Okay. X plus 3 is also a factor. Okay, clear? Now check x minus 3. Now we will check x minus 4. So in x minus 4, therefore my g of x is equal to x minus 4 equal to 0. So therefore what is my value of x? My value of x is equal to 4. My value of x is equal to 4. Therefore, value of x is equal to 4. So I'll put the value of 4 into p of x. That there is 4 cube minus 3 into 4 square minus 10 into 4 plus 24. That is 4 cube is 4 4 is 16, 16 4 is 64. Minus 3 into 4 square 16 minus 40 plus 24. Therefore 60 minus 48 minus 40 plus 24. Here is my 64 plus 24, that is 4 plus 4 8, 6 plus 2 8 88 minus 48 in minus 40, that is also 88 is equal to 0. For this condition I am also write that x minus 4 is also a factor. Okay, clear students? This kind of method we already learned in the previous lectures. Okay, but now we have to use condition, that is factor theorem. Okay, there is nothing changes between them. Now we are moving on. If there is not any kind of the value of any, now we are moving on. If any kind of these zeros are not given, then what can we do? Till now we are learning about there is two variables, p of x and g of x are given. Okay, till now we are learning about there are two polynomials are given as a p of x and g of x, and we are checking that g of x is a polynomial factor or not. Now here only p of x are given. Here only p of x are given, and say that factorize them using factor theorem. That is x cube plus 6x square plus 11x plus 6. Okay, there is not given any kind of g of x in the question, and they say that using factor theorem, using factor theorem, factorize the given polynomial. Okay, so there are two things we have to done. First thing, we have to must to use factor theorem, and second thing, that is we have to factorize them. Whenever we have to factorize cubical polynomial, we found three zeros of the polynomial. As for the first lecture, we have to learn. In the quadratic, we have to count two zeros, and this here is a cubic polynomial. Then we have to count three zeros of the polynomial. Okay. So first of all, we have to find any one kind of g of x. There is a g of x is missing, so we must to find g of x. Okay, then how to find g of x? We have to assume that or let value of x. We have to assume that value of x and contain, and that also contain remainder equal to 0. Okay, and also contains remainder is equal to 0. Then in which method we have to define remainder equal to 0? In remainder theorem. Okay. So I'll start using remainder theorem, that let x equal to 1. First of all, we have to assume that value of x is equal to 1. Now I'll put the value of x, p of 1 equal to 1 cube plus 6 1 square plus 11 into 1 plus 6. Therefore 1 plus 6 plus 11 plus 6. Therefore my answer is 6 plus 6 12, 12 plus 12 24. So here my remainder is 24. My remainder is 24. Therefore x plus 1 or value of x is not a factor of the given polynomial. Here my remainder 24 is not equal to 0. Therefore I am not taking value of x in this given polynomial as a g of x, as a g of x. So what is the next step? Then next step we also find take. Now I'll take as a minus 1. Now I'll take minus 1. So in the minus 1, that is minus 1 is equal to minus 1 cube 6 minus 1 square plus 11 into minus 1 plus 6. That's 4 minus 1 plus 6 minus 11 plus 6. Give me 6 plus 6 12, 12 minus 12, that is 0. Here my remainder is 0. Here my remainder is 0. Therefore g of x is equal to x equal to minus 1. Therefore minus 1 shifted on the second side. So my what is my answer? That is x plus 1 equal to 0. Now we say that x plus 1 is a factor of given polynomial. Okay. Therefore I'll take in the sum g of x as a x plus 1. Okay. So in the today's lecture we have to consider that values of x, and assuming the values of x, that is which kind of factor are there. Okay. So from the today's lecture we are moving also on the next lecture to find factor using factor theorem factorize the cubical polynomial. Okay. We are moving on next lecture to the find or using factor theorem factorize the given polynomial of the cubical polynomial. Okay. So these all kind of the things you must remember in your mind. So in the next lecture you have to clear all things. You must clear all things that I teach you. Okay. I am also repeat all these things. Okay. But you must remember all these things from now. So I am giving you some homework for the today's lesson or today's session. I am repeating all these things of the factor theorem and factorization of the cubical polynomial. But for today's lesson, for today's session, you must remember what can I teach you. Okay. What can I teach you, and what I tell you that methods of the cubical polynomial. Okay. So today's homework is, please write the today's homework. First question is, check given polynomial g of x is a factor or not of this p of x. Okay, g of x is a factor or not of this p of x. So my question is 3x raised to 4 plus 17x cube minus 9x square minus 7x plus 9x square minus 7x minus 10, and my g of x is x plus 5. Second question is x cube minus 6x square minus 19x plus 84, and my g of x is x plus 3. X cube minus 6x square minus 19x plus 84, my g of x is x minus 7. Sorry, my g of x is x minus 7. Third one is x raised to 5 plus 3x raised to 4 minus x cube minus 3x square plus 5x plus 15, and my g of x is equal to x plus 3. Okay, and the last question is, show that x plus 4, x minus 3 and x plus 7, sorry, x minus 7, write x minus 7 are factors of x cube minus 6x square minus 19x plus 84. Okay, so students, this is your homework, and please notify me whenever you complete your homework. Okay, so you must to remember all the things that of this using factor theorem, factorize the given polynomial of the cubic polynomial, and we are moving on to the next step. After this, we are moving on the next step using long division. After this, we have to do long division. Okay, to solve this sum. Okay, then you must to remember all these things that I teach you. Okay, so till then, goodbye and stay blessed.